All right, here's our next video in section 11.6. We're going to continue talking about OR probabilities. Remember we just saw in the last video that OR means to add, but this time we're going to talk about what happens if these events are not mutually exclusive, so if they could happen at the same time. So think about a deck of cards. If I ask you for the probability of not landing, but picking a diamond or a face card, well, think about all the diamonds that there are. Think about all the face cards that there are. Do you see how some of them overlap? These king, queen, and jack of diamonds, you included in the first group and in the second group. You've actually included them twice, so you've doubled the number unnecessarily. So anytime we have a non-mutually exclusive event, they can happen at the same time, and we want to figure out the probability of getting a diamond or a face card. What we've got to do is figure out the probability of the first event, in this case a diamond, then figure out the probability of a face card, add them together. But if there's any amount that I overlapped, I included twice, we have to then subtract out that overlap because we included the king, queen, and jack twice. So our answer is inaccurate if we include it twice. Okay? All right. So look at this example number 4. It's kind of a silly example, but bear with me. It says, in a group of 25 baboons, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy doing both. If one baboon is selected at random, find the probability that it enjoys grooming its neighbor or screeching wildly. Couple of key words: probability, what you want, add a total, and then the word or. Remember, the word or means add. But now we've got to be careful. We've got to worry about if these events are exclusive or not mutually exclusive. So let's look. I have the probability of grooming their neighbor plus screeching wildly. But be careful. The probability of this baboon grooming its neighbor is 18 out of 25. The probability of enjoying screeching wildly is 16 out of 25. But aren't there some baboons that enjoy doing both? So now you've included them in both pieces and you've overlapped. So what you have to do is make sure that you subtract off any of the duplicates or overlaps. And so how many baboons like doing both? 10, right? So I've got to make sure that we subtract out those 10 because you included them both times, and then your number is going to be way too high. Making sure that you subtract off the ones that you included both times, you should end up getting a probability of 24 out of 25. So be careful. Make sure you think about the situation and if any of them overlap or duplicate. Let me show you a few more examples here. Example number 5 says, find the probability that the pointer will stop on an odd number or a number less than 5. So I've got a probability of an odd number, I've got a probability of a number less than 5, and I've got the word or, so I know or means we're going to add. Now if I look at the spinner, what's the probability that I'll land on an odd number? Well, my odd numbers are 1, 3, 5, and 7. So isn't that 4 out of 8? And what's the probability that I'll land on a number less than 5? Well, isn't that 1, 2, 3, and 4? Isn't that 4 out of 8? Now be careful. You can see that I've circled them in purple and in orange. And haven't I actually circled the number 1 and 3 twice? So I included 1 and I included 3 twice in each of these situations. And so when I include them twice, I've just duplicated that number. I've included them way more times than I need to. So I need to make sure that I subtract out the duplicates. Remember, I added 1 and 3 twice, so I've got to take out the 2 numbers that duplicated in both of the different probabilities because these are not mutually exclusive. I've got a 4 out of 8 plus a 4 out of 8 minus 2 out of 8. You should get a final answer of 3 out of 4. The probability that you'll land on an odd number or a number less than 5 is 3 out of 4. Make sure that you think about those overlaps or the duplicates. That's the most common mistake I see. Students forget about the duplicates. Let's do one more. This one's a little bit different. This is one of our empirical probability questions. So it gives us a chart and it's going to ask us a few questions using the chart. In example number 6, it says if one person is randomly selected from the population in the table, find the probability that the taxpayer had a taxable income of at least $100,000 or was not audited. Probability, again, is what we want out of the total. I see or, so that means I'm going to add. So I'm going to figure out the probability that they make at least $100,000. That means greater than or equal to $100,000. Or means add. They were not audited. But then I've got to think about, is there any duplicates? Can I make at least $100,000 and not be audited at the same time? And if so, then I've just included that twice and I need to subtract off one of the times that I overlapped. So let's go through and find the probability of each. I've got to find the probability that I make at least $100,000. Looking at the chart, I have 12,893,802 people that made at least $100,000 out of a total of 122,158,336 people. That's what I want at a total. Find the probability now that you were not audited. Well, how many people were not audited? That's the 121 million out of the total of 122 million. But if you look at the chart, aren't there some people that made at least $100,000 and weren't audited? Didn't I include that group twice? So because there was some overlap there, I have to make sure that I take out that 12 million from the total because I've included it twice. Using those numbers and my calculator, of course, I ended up getting a probability of 121,341,746 out of the total. You can put it in your calculator. You should end up getting 0.99 or 99%. That means 99% of people made over $100,000 or weren't audited. All right, let's do another one. Here's part B. Maybe you could pause the video, look at your chart, and see if you can do part B all by yourself. Let's see. All right, part B says the taxpayer had a taxable income of less than $25,000 or in between $50,000 and $99,999. I have the probability of making less than $25,000 or means add the probability of making between $50,000 and $100,000. We've got to think about subtracting any duplicates if there is any. So go back to the chart, figure out what's the probability of making less than $25,000. Well, the people that made less than $25,000 were the 51 million out of the total 122 million. Now go back to the chart and figure out how many people made between 50 and 100. The amount of people that made between 50 and 100 looks like it was the 26,463,973 out of the total. Now be careful. Go back and look for any duplicates. Here's the column that made less than 25,000. Here's the column that made between 50 and 100. There is no duplicates, right? You're either going to make less than 25,000 or between 50 and 100,000. They're not going to be able to make both. And so in this example, I tried to trick you. There are no duplicates. But you still got to think about it because if there is some, it does make a difference. But there is no way that you can make less than 25,000 and in between 50 and 100,000 at the same time. There are no duplicates on this one, so you wouldn't have to subtract. You end up getting 0.64 or 64%. All right, so make sure you think about the duplicates. There's not always duplicates, but when there are, it does make a difference. So make sure you're paying attention to the situation to see if there's any time that you overlap, and make sure you subtract that amount out. All right, keep practicing. We have one more idea in this section in the next video we'll cover.